Let's continue with our experiments with the pixels array. In the last episode, we used three functions called red, green, and blue. And let's look in the reference what it says about them. Reference here on the help menu. And here on the top right, we have color. And these are the functions we have been using: red, blue, and green. Let's open one of them. And we can see here that the blue function extracts the blue value from a color. So here we are creating, in this example, a color that has 0 amount of red, has some green and a lot of blue. And then here later, it's reading the amount of blue from this color. The function blue of C would return 255. This is red, green, and blue. In this example, it doesn't make so much sense to read the blue of a color because we already know the amount of blue here. We wrote it ourselves. We can see this is 255. But when we are dealing with pixels from an image, we never know what color is each pixel. So that's why we have to use these functions like red, green, and blue. Now let's experiment with these other functions called hue, brightness, and saturation. They work the same way. We can have a look here. We are creating a color that also has, in this case, this is hue, saturation, and brightness. And the function brightness of C is returning the amount of brightness. So it would be, in this case, 255. So let's try it out. I'm going to first load an image here. Image img is load image big.png. And I'm going to add that image here, add file, big PNG. And I'm going to display the image img 00. We can run the program to see that it's working. And we can see how the original image looks like. Great, so now let's go through every single pixel here. Let's make here a for loop. For int I is 0, I is less than pixels.length, I plus plus. Before we can access the pixels array, we have to use load pixels, otherwise it will not work. And here I missed an H. So load pixels. And after doing here some manipulation on our pixels, we will call update pixels. Okay, so now we are ready to do some changes to our pixels. To get started, let's start by reading the brightness of our pixel. I'm going to say here float b, like brightness, is equal to the brightness of the current pixel. And the current pixel is pixels I. So now in the variable b, we have a number that indicates how bright is this pixel. Now let's do something different this time. Instead of just modifying a little bit, red, green, or blue, or the hue, brightness, or saturation, what I'm going to do is I'm just going to look at how bright this pixel is. And if it's very bright, then I will use a white color for the pixel. And if it's not so bright, then it's going to be black. So it's just going to be a black and white image. Just two possibilities. So I'm going to write here if b is greater than, I don't know, let's say 160. We know that b can be a number between 0 and 255. So in this case, this means it's a bright pixel. Then pixels I is going to be equal to color 255. So this is white. And otherwise, else, this means that the pixel was not so bright. Then I'm going to say this pixels I is color 0. So let's run the program and see what do we get. Well, this looks a little bit like a comic. And now depending on this number, the 160 here, this is like the threshold. Let me explain that to you here on an image. Imagine this is a line with all the possible brightness. This is black here, and this is white. And in the middle we have different shades. All the colors are somewhere here, maybe red, green, blue, orange. Each color has certain brightness. So we are putting some kind of limit here. In this case, this was 160. And we said that all the colors that are brighter than that, they are going to be white. Doesn't matter exactly which kind of color it was, just that the brightness was greater than 160. And otherwise, all the other colors are going to be black. So all kind of different shades of gray and dark greens and dark blues and dark reds, they are all going to be black. So if I change this number, if I push this line more to the right, let's say here, then there are less pixels that are going to be white, only these ones here on the right. And all the others, all these pixels here, which are darker than this limit, are going to be black. So let's try to put a number bigger than 160. I'm going to say here, maybe 200. And now the image should be darker. See, now almost everything is black. And what if I use a smaller number, like 100? Now you can see, this is quite nice. You can see now very well the bicycle here, and it looks like the shadow of the bicycle. But some part here are missing the details. So this is one thing you can do by reading the brightness. Now let's do something else. Let's reduce or increase the saturation of the pixel. So I'm gonna read the other information about this pixel. I'm going to say float S is saturation of pixels I, and float H is gonna be the hue of pixels I. So now we have all this information, the brightness, the saturation, and the hue. Now instead of making a conditional, I could just define a new color here, depending on HSB. If I would use hue, saturation, and brightness, first we're gonna get a funny result. Do you know why? Let's see, let's run the program and then see if you can think of. That's quite cool actually. Very beautiful colors. Do you know why this is happening? What do the parameters inside the color function mean? By default they mean red, green, and blue, unless we used color mode HSB. But we didn't do that. We didn't write here color mode HSB. So that means now that we are using the hue for the amount of red, the saturation for the amount of green, and the brightness for the amount of blue. So we get this very nice colorful image. Let's try now by setting here color mode HSB. When we execute this function, we are changing the meaning of the parameters inside the color function. Now this actually means hue, saturation, and brightness. So now if you run the program, we will get the original image. So what happens if we say we don't want any saturation, just 0? That's a very easy way to make the image black and white. What happens if we change the brightness and we say here just use 30%? When we multiply by 0.3, we are reducing the brightness. So if we now run the program, we have a very dark image. If we will multiply it by 2, then we will get a very bright image. You can see it's losing details here on this brown area. We could try also inverting some of these ranges. For example, I'm going to say that the brightness is 255 minus the brightness. So if the brightness was 0, then now we have a lot of brightness. 255 minus 0 is 255. That's a maximum brightness. And if before we had a brightness of 255, 255 minus 255 is 0. So this operation is inverting the brightness. This looks like some kind of X-ray image of our photo. Let's try to do the same with the saturation. 255 minus saturation. It looks like there's something strange going on inside these houses here. I'm going to get rid of this part here. And let's see now what happens just by inverting the saturation. That's quite nice. Nice posters here, and we can see some parts here are becoming really colorful. All these bicycle handle and different parts of this picture. Let's do a final example now, where we animate, for example, the saturation. Let's bring the saturation slowly down from having colors to having a black and white image. So I'm just gonna move all this block here, gonna cut this, and I'm going to put this inside the draw function. And now what I'm going to do is just generate colors which always have a little bit saturation. For example, saturation -2. So I'm reading the current saturation of this pixel, but then I'm using a value here which is 2 units smaller. So if it was 100, then it's 98. If it was 200, then it's 198. So the saturation goes a little bit down every time draw is called. Let's see what happens. So you can see that the saturation goes down. It doesn't go totally to 0, but we get a quite beautiful result, I think. We can try the same with the brightness, and then we have a fade out effect. Now the brightness goes down 2 units each time, and we can see that the image becomes black. So now it's your turn to experiment with these functions of brightness, saturation, and hue to manipulate the colors of the pixels on your photos.